All right, so today we're going to start looking at something called factoring. Okay, now factoring is unmultiplying. Okay, it's not quite division, but it's undoing multiplication. Okay, so for example, if I say 2 times 3 equals 6, that's multiplication. Okay, factoring is when you start with the 6 and you say, oh, well, I can write 6 as 2 times 3. Okay, so you're starting with something and you're breaking it down into what it multiplies into. So it's not quite dividing, it's just sort of breaking up things into things that multiply together to get those answers. Okay, so it's unmultiplying. And today we're going to look at just something called a GCF. Okay, so GCF stands for greatest common factor. Okay, greatest meaning the biggest, common meaning what do they have in common, what do they share, and factor, well, factors are these guys. If I can say that 6 is equal to 2 times 3, then we'd say 2 and 3 are factors of 6. Okay, so this guy right here, if that's my product, right, then these guys are my factors. Okay, so that's what we're kind of talking about here. So our GCF is the greatest common factor, which is the largest factor that goes into all of the terms. So we're looking for the biggest factor that goes into all of the terms. All right, so let's do some examples. So this first one, I'm going to start by looking at just the number part. I'm going to ignore the x's for now and just look at the numbers. So here I've got a 3 and here I've got a 6. And I want to figure out what's the biggest number that I can divide into both 3 and 6. Okay, so in this case, 3 is the biggest number that would go evenly into both of those, right? So I'm going to start by just writing down 3. That's the biggest number that goes into both 3 and 6. Then I'm going to look at the x's and I'm going to say, okay, this guy has 3 x's. This guy has 2 x's. So how many x's can I take from both of them before somebody runs out? Right? I could definitely take 1 from each of them and they both have some left over. I can take 2 from each of them, right? And then he would still have 1 left over, but he wouldn't anymore, right? I can't take 3 because this guy doesn't have 3 to give me. So the most I could possibly take is 2. So x squared is what I'm going to write down. So the 3 was the biggest number that evenly goes into 3 and 6. And the x squared, that's the highest number of x's that I can take before somebody runs out of x's. Okay, and now what we're going to do is we're going to have our parentheses. So essentially what we're doing here is we're undoing a distributive property. Okay, so you know how we've done problems before where we've had like 4x times 3x plus 2, and we've distributed it and said, well, that's the same as 12x squared plus 8x. What we're doing now is we're starting here and we're going back this direction. So this is what our answer is going to look like for this guy. Okay, so I've got my term in the front, and now I'm going to have the parentheses. Okay, so what goes in the parentheses? Well, I want to think to myself, if I were to do a distributive property, what would have to be here so it would multiply to give me that as my answer? Well, it would have to be 3 times 1 to stay at 3, right? And if I got 2 x's, how many x's need to be here so that I'll have 3? Well, just 1 more, so 1x. Okay, now the other one. So what do I have to multiply 3 by to get positive 6? Well, positive 2. And if I have 2 x's here, and I need to have 2 x's, so I have 2 x's, how many x's need to be here so I'll have 2 in the end? Well, none, right? Because we just wanted to keep the same. So that's it. That's our answer. So 3x squared times 1x plus 2. That's my factored form. And you can always check it by just doing a distributive property, right? If I did a distributive property, 3x squared times 1x would get me 3x to the third, and 3x squared times 2 would give me 6x squared. So I know I'm right. All right, let's try this guy. So same thing, we just have 3 terms. So we're going to do the same thing, start with the numbers. So I need the biggest number that evenly goes into both 2 and 16 and 8. Okay, so what I kind of like to do is I usually start with whatever the smallest number is, and I just think, well, what's the biggest thing that goes into this number? The biggest thing that goes into 2 is 2. So then just check, does 2 go into all the other ones as well? Yeah, it does. So I'm going to pull a 2 out in the front. All right, this guy's got 4 x's, this guy has 3 x's, that guy has 2 x's. So how many x's can I take from all of them before somebody runs out? Okay, if I take 1, they'll all have some left over. If I take 2 from each of them, this guy will have 2 left over, he'll have 1 left over, he won't have any left over. So that's what I'm looking for. Okay, 2 is the biggest number that I can take so that there's going to be one of these terms that doesn't have any x's left over. So I'm going to write x squared over here. All right, and then I'm going to factor that out. Okay, so this is going to be our distributive property part, right? So I'm looking, what do I need to multiply 2 by so that my answer will be 2? Well, 1. Okay, I've got 2 x's here. How many more x's do I need so that when I multiply these, I'll have 4 x's in the end? Well, if I've got 2, that means I need 2 more to get up to 4. So it's 1x squared. All right, so we did this guy. Now we're going to do the 16x to the third. So what do I have to multiply 2 by to get 16? Positive 8. So I'm going to write plus 8. And if there's 2 x's here, how many more do I need? So I'll have 3 in the end. Well, just 1 more. And that's it. That's our middle term. Now this guy. What do I have to multiply 2 by? So I'm going to get negative 8, negative 4. And if I have 2 x's here, how many more do I need here so I'll have 2 in the end? Well, none. I've already got the 2 that I need. So that's it. That's my answer. And again, you can double check. If you do a distributive property, make sure you get back to what we started with. All right, let's do another one. This one I had to fix a typo on. That's supposed to be a 15x squared. All right, so let's look at this guy. So I've got a 15 and a 10. And I want to start by thinking to myself, what's the biggest number that evenly goes into both 15 and 10? Okay, so I'm going to start with the smallest number. So 10 is the smallest number. What's the biggest number that goes into 10? 10 is. Does 10 go into 15? No, not evenly, so that won't work. What's the next biggest number that goes into 10? 5, right? Does 5 go into 15 evenly? Yeah. So that's the number I'm looking for. Okay, so I'm going to put 5 in the front. This guy has 2 x's. This guy has 3 x's. So how many can I take from each of them? Well, I could take 2. Once I take 2, this guy won't have any more to give me, right? So x squared. All right, and then for my parentheses, what do I have to multiply 5 by so that I get 15 in the end? So 5 times what gives me 15? 5 times 3 gives me 15. I have 2 x's here. How many more x's do I need so I'll have 2 in the end? Well, none. We've already got all the ones we need. Okay, so that's it for that one. So now let's do this guy. What do I have to multiply 5 by so that I'll get negative 10 in the end? So 5 times what gives me negative 10? Well, negative 2. And if I have 2 x's here, how many more do I need so I'll have 3 in the end? Just 1 more. And that's it. All right, last one. Okay, so let's start with our numbers. So I've got a 2, a 6, and the 18. So I'm going to start with the smallest number, which is a 2. All right, and I'm thinking to myself, what's the biggest number that goes evenly into 2? Well, 2 is. 2 is the biggest number that goes evenly into 2, right? So does 2 go into all 3 of these? Yeah, it does. Great, so I'm going to put a 2 on the outside. All right, then this guy has 3 x's, this guy has 2 x's, this guy has 1 x. So how many x's can I take from all of them before somebody runs out? Well, in this case, just 1, right? After I take 1 x away, this guy won't have any more. So I'm just going to have 2x here. All right, and now I'm thinking to myself, what do I have to multiply 2x by? So I'm going to get 2x to the third as my answer. Well, 2 times what gives me 2? 2 times 1. And if I have 1x and I need 3 in the end, how many more do I need? 2 more. All right, next guy. 2 times what is going to get me to positive 6? 2 times positive 3. And if I have 1x and I need 2x's in the end, How many more x's do I need? So 1x, how many more to get me up to 2? Just one more. And then this guy, 2 times what gets me negative 18? Negative 9. And if I have 1x here, how many more do I need to end up with 1 in the end? I don't need them anymore. I already have them all. Okay, and that's it. That is my factored form. Okay, so that is how we factor using a GCF. It's the greatest common factor. And remember, you can always double check your answers by doing a distributive property to make sure you ended up with the thing you started with.